Okay, we're looking at 4-7, inverse and identity matrices. An identity is a number that you can add to or multiply by, and not change the value of the number you're adding to or multiplying by. The identity for addition is 0, and the identity for multiplication is 1. There's also an identity matrix for multiplication. The identity matrix for a 2 by 2 matrix is 1, 0, 0, 1. In that order. Those exact signs, that exact thing. Okay, that's the identity matrix for a 2 by 2. If it's a 3 by 3, then your identity matrix looks like this. Okay, so you have to have square matrix to have an identity matrix. If you multiply two matrices and get the identity matrix as the product, the two matrices that you multiplied are inverse of each other. A to the negative 1 is the symbol for inverse of A. Only square matrices can have inverses. So if you have this matrix A, B, C, D, the first thing you do to get the inverse is find the determinant. So A times D minus C times B. That's your determinant. Okay, so the inverse is going to be 1 over the determinant times, then you're going to rearrange some of this in the matrix. You're going to switch the order of A and D, so you have D first and A last, and change the line of your other diagonal, or change the sign, sorry, negative C and negative B. And that would be your inverse. Okay, so this determinant cannot equal 0, or it will make the whole thing undefined. So if it equals 0, then you would say not possible or does not exist. So let's look at number 1. Number 1, it wants you to determine if the following are inverse matrices. So it's just a yes or no question. And they give you 2, 2, negative 1, 4, 1 half, 1 half, negative 1, and 1/4 for the other matrix. So I'm going to multiply these together. I'm going to take the first row times the first column. 2 times 1 half is 1. Add them together. 2 times negative 1 is negative 2. So what value am I going to get there? Negative 1, which is not going to give me the identity matrix, right? It's not the right sign, so I don't have to do anything else. It's just no. Okay, so you guys try number 3, and I'll do it up here. All you're doing is seeing if they're inverses of each other. Okay, so those two matrices are inverse matrices. Any questions? All right, let's look at the next part. We're going to find the inverse of S on number 5. Is everybody finished with this? Okay, so let's look at number 5. The original matrix is negative 1, 0, 8, negative 2. Okay, so to get the inverse, the first thing you want to do is find the determinant. So I'm going to take negative 1 times negative 2, and then subtract 0. So your determinant is 2. All right, so your inverse, 1 over the determinant, and then we're going to rearrange the matrix a little bit. I'm going to switch the first diagonal order. So I put -2 first, -1 last. And then I'm going to switch the signs of the other two terms, -8 and 0. And that's all you have to do to get the inverse. You don't have to multiply through by that 1/2 or anything like that.
So you don't need to multiply now?
You can just leave it like that with the fraction out in front.
Where did the 1/2 come from? This. Where'd the half come from?
From the equation that we used to get the inverse, it's 1 over the determinant times the matrix, and we rearrange the matrix a little bit. Okay, so you guys do number 8. Find the inverse for number 8.
We don't have to finish it?
You can leave it in that form.
Both of them?
Can you do another one with the ones at the top?
Let's do number 4 from the top. Okay, let's look at number 4. We're going to determine if they are inverses of each other. So in order for them to be inverses, I need to get the identity matrix whenever I multiply them together. So I'm going to take the first row times the first column. 3 times 1 is 3, plus -1 times 2 is going to be -2. And the first row times the second column. 3 times -3 is -9, plus -1 times 4 is -4. Am I going to get a 0 there? The order is supposed to be 1, 0, 0, 1. So is that one going to work?
No.
No. So you just say no. They're not inverses. Okay, so let's look on the other side. 4, 8. Using matrices to solve systems of equations. So yesterday we solved systems using Cramer's rule. Today we're going to solve systems using inverses. Okay, so the first step to solving a system using matrices is to write a matrix equation for the system. So you're going to have the coefficient matrix, the variable matrix, and the constant matrix. So like on number 1, you have your two equations. The coefficient matrix is a row of your column of your x coefficients, column of your y coefficients. So you're going to have 1, 1, and 3, 2. And we're going to call this matrix A. Beside that, we have the variable matrix where you just have the x and the y in a column. We're going to call that matrix X, and then it equals your constant matrix. So we'll call a matrix, and we're going to call that one matrix B. So the way that the matrix equation is set up, it's A times X equals B. Okay, so to get the values for X and Y, to find out where they intersect, I'm going to rearrange this A times X equals B. We're going to make this the variable equation equals A to the -1 times B. So I'm using the inverse of A, taking it times the constant matrix. And it needs to be in that order. It won't work if you take it B times the inverse. It doesn't work. All right, so I'm going to find the inverse for A. The determinant is 2 minus 3. It's 1. So your variable matrix is going to equal, that's -1, sorry. -1 times, got to rearrange the order in the original matrix, change the sign of the other diagonal, times the 3, 7. Okay, so I'm going to multiply the matrices together first. I'm going to take the first row times the column. 2 times 3 is 6, plus negative 3 times 7 is negative 21. And negative 1 times 3 is negative 3 plus 7. And that's all going to be multiplied by your 1 over negative 1. So you're going to wind up with, for your x and y, 15 and negative 4 after you combine your terms and then change the sign. And you want to write your answer as a coordinate because it's where they intersect.